Very fine. Good morning, Manandal present here. My special good morning to Mr. Sheikh Majid sir. Today's gate trainer, the same resource person which we had in the previous classes. On behalf of Francis Xavier Engineering College, Department of Electronics and Communication, and behalf of AICTE Prerana Scheme, I welcome you, sir. Over to Mr. Sheikh Majid sir. Majid sir, shall we start?
Hi, sir.
Sir, you can now start the session, sir.
Okay.
Thank you, sir. Thank you.
Okay, sir. Hi, students. In this class, we see wave propagation in detail, which is a very important part in a GATE examination, right? So minimum you can expect 3 to 5 marks from this area. So let us start now. The agenda in this class is we are going to learn about Poynting vector, plane wave properties, and propagation of wave through various medias, right? So before learning wave propagation through various medium, we must understand phasor form of Maxwell's equation. From Maxwell's equation only, we come to know that a wave can be propagated. So first, this must be written in the form of phasor, right? So let us start with Maxwell's equation. We know that from Maxwell's equation, del dot D is equal to rho V. Del dot B is equal to 0. Del cross E is equal to minus dou B by dou T. Del cross H is equal to sigma E plus epsilon dou E by dou T. This is what the Maxwell's equation. This is Gauss law for E field, right? This is Gauss law for H. This is magnetic field. Third one is Faraday's law. Fourth one is modified Ampere's circuital law or Maxwell's Ampere law. So how to convert this equation into what you call phasor form? Sorry. So let's see how we are converting. If you want to convert any equation into phasor form, what we have to do is we have to replace dou by dou T by j omega. Fine. So the phasor form of Maxwell's equation now we get is first equation, we don't have any dou by dou T here. So first equation remains as it is. Del dot D is equal to rho V. Second equation, here also we don't have any dou by dou T. So it will become del dot B is equal to 0. Third equation, we have left hand side del cross E Right hand side we have dou by dou t. So replace that by j omega. Right? J omega b. We know b is equal to mu h. So it is j omega mu h. Fourth equation, del cross h. That is right hand side sigma e. We cannot change it. Epsilon. Then we have dou by dou t. That is j omega. And e is that e. So this I can simplify as okay, e sigma plus j omega epsilon. This is what we know as phasor form of Maxwell's equation, right? Okay. So this we must remember, especially we are going to use these two equations in the later session. So please remember at least this. Del cross H is equal to sigma E plus j omega epsilon E. Fine? Okay. Next thing we have to learn is intrinsic impedance of a wave, right? What is intrinsic impedance? What does it mean? Things are very important. So let us start learning that. So first thing we have to know about intrinsic is what impedance. It is an impedance encountered by a wave when it propagates through medium, through any medium, right? So it is just like impedance encountered by a current when it is propagated medium, right? Like that, intrinsic impedance is a impedance encountered by a wave, whereas the impedance of in a circuit area, electronic circuits, any communication, anything is impedance encountered by a current. Here encountered by a EM wave, right? So you can say encountered by a EM wave when it propagates through any medium. Okay. So what is the formula to find the intrinsic impedance? Is in is equal to E by H, right? Eta, sorry, it is not N, it is eta is equal to E by H. How it has become an impedance? There is no relation such as impedance means we know it is a voltage by current. We know what is the unit of E. E is electric field. E is volt per meter. What is the unit of H? It is ampere per meter. So ampere per meter, it will go up. Meter cancel. So it will become volt by ampere. What is volt by ampere? Which is nothing but the impedance. V by I. That's what that is equal to Z. So eta is equal to E by H defines intrinsic impedance. Fine? Okay. So the for intrinsic impedance is eta is equal to root of mu by T, epsilon. So please learn this concept very clearly because for the whole 3 hours we are going to use this term regularly. So we must know what is intrinsic impedance. Eta is equal to mu by epsilon. We know mu is equal to mu naught. Epsilon is equal to epsilon naught, epsilon r. Where E is electric field, H is magnetic field, mu is permeability, epsilon is permittivity. Okay, then we must know this is what eta in any medium, formula for eta. But if for free space, we know that for free space, mu r is equal to 1, epsilon r is equal to 1. This implies eta is equal to, mu naught mu r is 1, naught epsilon r is equal to 1. So mu naught value, it is absolute permeability, that is 4 pi into 10 power minus 7. Epsilon naught we have studied in Coulomb's law itself. It is 8.854 into 10 power minus 12. Right? Mu naught is absolute permeability. This is absolute permittivity. Mu r is relative. R means relative. Mu is permeability. Epsilon r relative permittivity. So this will give 120 pi, or the equivalent value is 377 ohm. Since eta is the impedance, the unit is ohm. So eta is equal to 120 pi or 377 ohm for free space. So when wave travels through a free space, what happens? It encounters an impedance of 377 ohm. That is the meaning. For other medium, eta is equal to, there is one more definition. Intrinsic impedance eta is equal to Z omega mu divided by Z omega epsilon plus sigma. In free space, the conductivity is 0. Right? So if you substitute 0 here, what you get is, what will happen? It will become mu by epsilon. Because when sigma 0 here, j omega mu by j omega epsilon. So j omega cancel. It is mu by epsilon. That's what we have done already, mu by epsilon. So this is a third equation. So for intrinsic impedance, we have three formula. Eta is equal to j omega mu by j omega epsilon plus sigma. This is the first formula. Eta is equal to E by H. Eta is equal to mu by epsilon. This mu by epsilon has come from this equation only, right? For free space, it will be mu by epsilon. Right? You can use any formula depending upon the parameters given in the gate problem. I hope you understand what is intrinsic impedance and everything. Right? So this is the impedance encountered when a wave propagates through any medium. The value for intrinsic impedance, so for free space is 120 pi or 377 ohm. These are all the things you must remember. Okay, now we start with pointing, right? Let us start. So what about pointing vector? Pointing vector, why we have to study pointing vector? Pointing vector proves that electromagnetic waves carry energy. How it is carrying energy, let me tell you in the next slide. So what are the things we have to learn from the pointing vector? It proves that electromagnetic waves carry energy. The next thing, what this pointing vector states is, when a wave propagates through any space, what happens is it transfers the energy to object in their path. This is another important point we learn from pointing vector. So what pointing vector defines, it specifies the rate of flow of energy in an EM wave. Right? So the rate of flow of energy in an EM wave is described by pointing vector S. The symbol for pointing vector is S. So it indicates the energy flow or power flow in an EM wave. Let us see how it has described everything. So the pointing vector is defined as, I told it is specified by S vector. This is what pointing vector S is equal to E cross H. right? So where E is an electric field, H is a magnetic field, S is a pointing vector. The next thing I am writing here is the pointing vector has units of watt per meter square. How it has units of watt per meter square? Let me tell you. Right? Okay, as I write here itself. We know S is equal to E cross H. The unit of electric field is volt per meter. The unit of magnetic field is ampere per meter. So that if you multiply, because this cross multiplication, when you take multiplication, VA by meter square. V is volt, A is ampere. So when you multiply voltage and current, what you get is watt. Here we get power. So the unit of voltage, the unit of current will give unit of power. That is meter square. So the unit of pointing vector is watt per meter square. This question they have asked already. So you must remember. So you see, since it is a vector, S has both magnitude and direction. So what is the direction of S? The pointing vector has the same direction as the direction of propagation. So S has the direction which is equal to the direction of propagation of EM wave. How? Let me prove in the next slide. Then what is the pointing vector at any point is equivalent to power density of the wave at that point. So the magnitude talks about power density and the direction is the direction along the EM wave. Okay, how this is the magnitude. The second point is talking about magnitude of the pointing vector at any point is equal to, okay, right here. The magnitude of pointing vector at any point is equivalent to the power density of the wave at that point. Since S is a common vector, it has both magnitude and direction. Why magnitude is talking about power density? You see, population density is population per area. Power density must be power per area. You know, meter square is area. This is power. So power per area is power density. So the magnitude of the pointing vector at any point is equivalent to the power density of the wave at that point. Now we will see how the direction of pointing vector gives the direction of propagation. Let us see. S is equal to E cross H. Right? The question is how it is a power flow. Right? Already we know it is S is equal to power. How it is power flowing in the direction of EM wave propagation? We know in electromagnetic wave, in the last session itself, I told E and H are perpendicular to the direction of wave propagation. E is perpendicular to H. Both are perpendicular to direction of propagation. This we learned from our school days itself. In electromagnetic waves, E and H will be perpendicular to each other and perpendicular to the direction of propagation. For example, if E is along the, if wave is along the X direction, on the day we studied, if wave propagates in X direction, electric field will be in Y direction. This is the direction of E. This is the wave direction, and magnetic field will be along Z direction. That's what mutually perpendicular. So it is coming out. This is coming out, not going down. This I cannot draw. It is like it's coming out. So here the wave is going in Z direction. Sorry, magnetic field is in Z direction. Wave is in X direction, and electric field in Y direction. This is what the meaning. But how E cross H proves this theorem? Let us see. Right. So we know that whenever you take a cross product of two vectors like A cross B, let us assume the result is C vector. What is the direction of this A cross B? We know A cross B is equal to mod A mod B sine theta n cap, that is equal to C vector. That means what? If you take a cross product between two vectors, the resultant vector will be equivalent to magnitude of first vector, magnitude of second vector, sine of the angle between first vector and second vector, and the direction will be perpendicular to both A and B. So what is the thing? If A is in this direction, right, and B is in this direction, where will be A cross B? That is the question, right? So where will be our C? C is nothing but A cross B. So whenever you want to know in which direction A cross B will be there, use the simple rule I'm telling you now, right? Here we have to take A cross B. So assume that we have to go from A to B, right? So when you want to go to A to B, we are going in the anti-clockwise direction, right? When you rotate anything in anti-clockwise direction, what will happen? It will come out. You take water bottle and rotate the cap of the bottle. Assume that you are having water bottle in your hand and you rotate like this, right? Here I have water bottle, I rotate like this. If I rotate in anti-clockwise direction, what happens? It is coming out, right? So what will happen? The result will be coming out. So C will be coming out. That is the meaning. So that means if A is in this direction, B will be in this direction, then our C will be coming out of the screen. That means C must be perpendicular to both A and B, so it must be coming out of the screen. So I put like this. This is what C. Coming out is indicated by the symbol dot like this, right? So when you rotate anything in anti-clockwise direction, the result will be coming out. Are you understanding the logic? Okay. Similarly, suppose I want to find B cross A. Let me find B cross A. What about B cross A? Right, A is here, as in the diagram. B is here. I want to B cross A. That means I move from B to A. Now I move in the clockwise direction. When I move or rotate in the clockwise direction, what happens? You see, whenever you rotate any object in the clockwise direction, what will happen is it will go inside. Right? Here you see, I have a water bottle. I rotate in the clockwise direction. If I rotate it, so go inside will be represented with the cross. Hope you are studying all the things in mathematics. C is going inside. That is going inside, right? So coming out is represented by dot. Going in will be represented by the cross. So here the resultant vector go towards the screen, go inside the screen. That is, it is perpendicular to both A and B. A is in direction. C is going inside the screen. Now we come to our power flow. S is equal to E cross H. Right? If, as we assumed, if E is in Y direction, right, and H is in Z direction, right, where will be, yes, the electric field or EM wave, EM wave is perpendicular to the direction of both E and H. So E is in Y direction, H is in Z direction. So wave should be in X direction only. That is, it is coming out. I can say it is dot, right? So this is what wave direction, wave propagation. Because all the things be perpendicular to each other. Fine. Here you see when you move from E cross H from this diagram, right? So E to H I have to move. So E cross H, I am rotating in anti-clockwise direction. So just now only I told whenever you rotate anything in anti-clockwise direction, it will come out. So surely it is coming out. That's what I have already done here. So yes, the direction of S indicates. This is what S direction. right? So this is E direction, this is which direction? So S direction. If electric field is no direction, magnetic field is Z direction, wave will propagate in X direction. So this is the direction of wave propagation. Similarly, it is the direction of pointing theorem, pointing vector. So the direction of pointing vector indicates the direction of wave propagation. Similarly, the magnitude indicates power density, that is power at particular point, a particular area. So power per meter square. Right? This is what we must know about pointing theorem. So now I hope you understand how pointing theorem is dealing with power flow. Power flow of the EM wave is along the direction of power flow of wave propagation. This is a very important concept, right? Okay. So next, sorry, pointing theorem. Here you see, this is what a pointing theorem. So no need to derive all the things, just you understand what is pointing theorem. So excuse me. So you see here, this is sigma E square, right? It is talking about power dissipation as heat. So it is loss of power. Already we know 1 by 2 mu h squared is energy stored in magnetic field from our electromagnetic field. We know electric stored by magnetic field is half mu h squared. That's what energy stored in magnetic field. It is changing with respect to time. So dou by dou t, rate of change of energy stored in magnetic field. Next you see of epsilon E square. This we studied already. It is rate of change of energy because dou by dou t is rate of change of energy stored in electric field. So you see left hand side indicates power flowing into the region. Right? Already we know E cross H indicates power flow. Right? Minus indicates into, plus indicates out of. Fine, here it is plus, here it is minus. So E cross H indicates power flowing into the region. When power flows to any region, as per the law of conservation of energy, some of the power is dissipated as heat, some of the power is stored in electric field, and some of the power is stored in magnetic field, some of the power is stored in electric field. This is what total power entered into the region. This is what pointing theorem, right? If you want to know how this representing a magnetic energy, how it represents electric energy, please refer my video on EC8451 electromagnetic field, right? So there I explained everything. So if you want to prepare properly with the proper meaning of gate examination in electromagnetics, please refer this playlist. I have covered everything in detail. That will be really useful for you, right? The site is Majid Lectures. I have solved so many problems in that and put a lot of videos for all the gate exam subject. So it will be really useful for you. Okay. So next thing we have to remember is complex pointing vector. Complex pointing vector, this is what S vector. So S, you put like this, S is equal to 1 by 2 E cross H. This is what complex pointing vector, 1 by 2 E cross H. Star, it is complex conjugate. So next we have to remember is, since it is a complex number, it has both real part and imaginary part. Right? So we know real pointing vector. From this we learn what is real pointing vector. Real pointing vector, this is very, very important. Our other name is average pointing vector. PV is nothing but pointing vector. So P average, otherwise S average is given by 1 by 2 real part of E cross H. That's what it is, not multiplication, it is E cross H. Similarly, imaginary pointing vector is known as reactive pointing vector. Reactive pointing. This is very important. Please remember, reactive pointing vector is known as S react. That is given by 1 by 2 imaginary E cross H star. Fine. Okay. So we have also indicated. So S is equal to 1 by 2 yes, average pointing vector E cross star. So we know already. I don't if I find magnitude, is average. Here magnitude means product, so mod E, mod H, sin, and between E and H are multipliers, sin 90. So 1 by 2 EH. Already we know eta is equal to E by H. This is E is equal to eta H. So 1 by 2 H is equal to E is equal to, okay. We substitute anything. This will give, otherwise this implies H is equal to E by eta. If you substitute H is E by eta, it is E squared by eta. This formula is very, very important. So average pointing vector is average is equal to 1 by 2 squared by eta. Based on this, we are going to solve a lot of problems. So please understand this very, very important. Average pointing vector or power density. Right? Okay. Now we go to the problem number 1. Right? Okay. So the question is the time average pointing vector. Just now only I told we are going to solve a lot of problems. Time average pointing vector in watt per meter square for a wave with E is equal to 24 e power j into omega t plus beta z ay whole per meter in free space. So what they have given? They have given E value. So E is equal to 24 e power j omega t plus beta z ay cap volt per meter. What they ask is average pointing vector. What is average pointing vector? Is average is equal to E cross H. That is what? E squared by 2 eta or 1 by 2 E squared by eta. So I need magnitude of electric field. Right? So what is the magnitude of electric field? Mod E. That is given by modulus of 24 e power j omega t plus beta z ay vector. That will give 24. Why? The modulus of e power j is 1. Modulus of e power j theta is 1. And ay is unit vector. The magnitude unit vector is also because the itself a unit vector. But that means it has magnitude. So mod e power j is 1. So it is equal to 1. So mod is vector and you know to 3 7 4. Now S average in magnitude is given by 24. E squared is 24 divided by 2 into 377. That will give what do you call 2.45 minus AZ. Right? So how I have written like this, let us see. Otherwise, you can say it is 24 square divided by 2 into 125. Because 377 is equal to 125. From the problem, the answer will be like this in pi. So you substitute 125. So you see 24 into 24, 245. So it is 1 by 10. So it is 2.4 divided by pi, right? How it has become minus AZ? The next question, right? So here you see the wave electric field, right? Electric field is going in minus z direction. So E is in minus z direction. The wave propagates in minus z direction. That's what I hope you understand from the last Maxwell's class. I told if will be x of minus vt plus x of plus vt format and a cos omega t minus beta z. If z is positive, so it is minus means the wave propagates in forward direction. If it is plus, wave propagates in reverse direction. So here minus beta z means forward z, plus beta z means it is reflected. So it is reflected. So it is minus z. So the wave is propagating in minus z direction. So the answer is 2.4 divided by pi, and it is minus z. Fine. So the average Poynting vector is 2.4 by pi minus az. Right? So this is what the answer. So you must understand why it is minus az. Right? Because that is in the wave propagates in minus direction. That's what we are understanding from the electric field. So you put minus az, 2.4 by minus az. The next thing, question is the electric field component of a time harmonic plane EM wave traveling in a non-magnetic lossless dielectric medium has a amplitude of 1 volt per meter. So E is mod E, that is equal to E, 1 volt per meter. It is a non-magnetic lossless dielectric medium. Relative permittivity of the medium is epsilon r, that is equal to 4. Relative permittivity. Magnitude of time averaged point density. That means they ask magnitude of average Poynting vector, that is E squared by 2 eta naught we have to find. So E they have given eta 125. Then what is the use of this one epsilon r, right? So that is what we have to remember. So we must know E is 4. Is so it is not, so we cannot use 125. Right? So what we have to do, so you see this I split as mu naught by into 1. So now it is 60 Here you see in the problem they are given non-magnetic lossless dielectric medium. It is not free space. So you have to, whenever you solve the problem, please give attention to the medium against. It is not free space. Yes, average is equal to E squared 1 divided by 2 eta naught, 2 into 65, it will be 1 by 125. The answer is option C. third question is, the incoming solar radiation at a place on the surface of the earth is 1.2 kilowatt per meter square. So they have given kilowatt per meter square. Watt per meter square means it is power density. Yes, average they have given. Right? That is 1.2 into 10 power 3 watt per meter square. What is the amplitude of electric field? So they ask what is E value. Right? So this is a very simple problem. S average is equal to E squared by 2 eta. Right? So this will, if there is no medium is given, the medium is assumed to be free space. This is equal to E squared 2 eta S average. E is equal to root of 2 eta S average. Eta is equal to 377. So 2 into 377 into 1.2 into 10 power 3. Right? So if you simplify, what you get is 951 volt per meter. That is approximately equal to 950 volt per meter. Option D is the right answer. Okay. Next question. This is one of the beautiful questions I have encountered. A plane wave in free space, so no issue. Has an average Poynting vector of 1.5 watt per meter square. What is the average energy density? Right? So free space, so eta is equal to 377. Average Poynting vector is equal to 1.5 watt per meter square. What is average energy density? Average energy density means it is 1 by 2 epsilon E squared. So if you don't know this, please refer my video playlist on PC845. Right? So I want E squared. So from these two values, I get E squared. Then I can solve. We know S average is equal to E squared by 2 eta. This implies E squared is equal to S average into 2 eta. S average is, they have given 1.5 into 2, eta is 377, right? It is 1131 E squared, right? So now I substitute 1 by 2. Epsilon is epsilon free space, so epsilon is equal to epsilon naught, that is given by 8.854 into 10 power minus 12. E squared is 1131. Simplify it. What you get is approximately 5 nanojoule, right? Energy density. So the answer is 5 nanojoule per meter cube. Density, so it is meter cube. Fine. So energy is joule, density joule per meter cube unit. Fine. And next question is, so here E is given like this, H is given like this. What is time averaged Poynting vector? So I have to find S average E cross H. Fine. So what is the thing? You see 1 by 2. Okay, 1 by 2 E cross H. Right. So 1 by 2 E cross H star. 1 by 2 E is nothing but, I write it in next page. S is equal to E cross H star 1 by 2. So 1 by 2 E is AX plus JY. AX plus JAY e power JZ e power J KZ minus J omega T star K by omega mu K by omega mu AY plus JAX AY plus JAX e power JZ minus K omega T. So e power J KZ, here it is star, that is conjugate. So minus J plus j k omega t. Hope you understand why. Because E is direct, H is star, so you have to take conjugate. So plus j means here it is plus j k z, right? So here it should be minus j. So similarly, you have to take minus here also. That is one more j, H star, right? Here also. Now you take 1 by 2, right? First I multiply this one. Constant k by omega mu is constant, k by omega mu, right? So ax cross ay. Ax cross ay is az. Right? Remaining thing I keep as it is, some factors. Then ax, what do you call? If you multiply ax with this, it will be minus, it will be plus. So opposite, so it will become 0. So a is it only. So it is nothing but ax e power j k z minus j omega t cross. This is ay e power minus j k z minus plus j omega t. So these two will give e power 0, 1, ax cross ay, az. Like that everywhere this e will give 1 only. So we have to multiply only these vectors. Ax cross ay, az. Ax cross ax 0. Ay cross ay 0. Ay cross ax is nothing but what do you call? Ay cross ax is, it is minus az, right? so what will happen? The result will become 0, right? Plus az minus az. So the resultant vector will become 0 vector, right? That's what we have to understand. So here you don't change this, right? You have to change the sign in the e power j only. So ay multiplied by ax, sorry, cross product ay cross ax is minus az. So the answer is 0. So it is a null vector. So whenever you take a complex conjugate of h1, this one you keep here this one you will change, right? Okay. Next, this one you can solve on your own, right? So the answer for this question is, I think it is 50 by eta. Fine. So this is 50 by eta. Try to solve on your own. If you have any doubt, please ask me in my channel or in the phone number I have given. So you can ask doubt in that question. Okay. So that's all about the things we must know about pointing theorem. Now we go to plane wave propagation in various media, right? So this is very, very important. Let us see what is the thing happening here. Okay. Right. Let me take water. Here you see constitutive relation. It is very important. Last class itself I dealt, but it is I ran fast. So let me go in detail now. Constitutive relation is nothing but these three relations are known as constitutive relation. It relates D and E. Second relation relates B and H. Third relation relates J and E. So these are all parameters. So E, epsilon, mu, and sigma. These are all free space parameters. So it is epsilon permittivity, mu is permeability, sigma is conductivity. This relation is applicable when the medium is homogeneous, isotropic, and source free. What is the meaning of homogeneous, isotropic, and source free? Let us see. The medium is known as homogeneous medium when the physical characteristics of the medium don't vary from one point to another point. So it is homogeneous means location independent. The characteristics of the EM wave is independent of the location. Everywhere it will be same. That's what homogeneous means. A medium in which the wave characteristics are independent of the location, right? In isotropic medium, whose properties are independent of location. We are talking about homogeneous medium. We have to talk about homogeneous medium. So, a medium in which wave characteristics are direction independent. It is called direction independent. Homogeneous medium means all the parameters, wave characteristics are independent of the location. Isotropic medium, all the parameters are independent of direction. The medium is called source-free medium if there is no voltage or current source, that is no generators, right? So in source-free medium, conductivity 0, right? Because there is no source and current density 0, charge density 0 because there is no charge. Here Q is also 0, that means Q0. A medium is called source free, Q0, rho V0, sigma 0, J0. Right? Another thing we must remember, source free means without source, then you can ask how the wave will be coming. That is the thing. That means the source is not present on the location, it may be located somewhere. Right? We have our home here, but the TV station may be somewhere here. Suppose let us assume it is a what you call colors TV. So it is somewhere here. We may be in Nagarkoil, right? The TV station colors TV may be in Mumbai, right? So when you see from Nagarkoil, you never see Mumbai. That's what source field. Source is there, but it is not present on the location you measure the field. Right? In your home, we feel EM wave which carries electric field and magnetic field. But source is somewhere. It is far away distance. Right? The distance is too far, and that's what no impressed V and I. If the source located here, we call it is impressed V and I. The source is somewhere far away distance, so it is called source-free medium. That means source is not present in the particular location where you are observing electric and magnetic field. Source is present somewhere else. That medium is known as source-free medium. Right. Next thing we have to remember about few important definitions, right? So what are those definitions? I want to clarify all the things. Otherwise, you may forget. The first definition is what you call velocity of propagation. That is V. We know how what is the meaning of velocity of propagation. So I skip this. Next one is beta. It is called phase shift constant or simply phase constant, right? So what is phase constant? It is the amount of phase per unit length, phase shift per unit length, right? So that's what phase constant. We know for any wave, let us see, this is a wave, this is 0, pi, 2 pi, the wavelength is lambda. What is beta from this? You can understand. See, for lambda wavelength, how much phase shift it has undergone? Here phase shift is 0, here phase shift is 2 pi. So for lambda wavelength, the phase shift is 2 pi. What is beta? Beta is phase shift per unit length. So for one length, what is the phase shift? That's what 2 pi by lambda. This is very, very important equation. For lambda wavelength, phase shift is 2 pi. What about phase shift per unit length, for one length? So that is what we know, 2 pi by lambda, 1, that is giving beta phase shift constant. So beta is equal to 2 pi by lambda. This formula we will use widely in GATE exam. That is what known as phase shift constant or phase constant. And the next one is phase velocity. Right? So phase velocity is nothing but velocity of EM wave, right? So at some point in the sinusoidal waveform. So that is what phase velocity. Another one velocity is there, that is what group velocity. So we must know the difference between these two, right? So we have studied as per the Fourier theorem, any periodic signal can be represented in terms of infinite sum of complex exponential, right? That's what we have studied in Fourier. A varies from minus infinity to plus infinity, a k equal jk omega naught t. So any periodic signal can be represented in terms of complex exponential. So when the wave propagates through a medium, a wave has so many frequency component. Many frequency component, right? So they will take different path, and finally at the receiver they add up and reach the receiver. So what is the thing is, I told a wave has so many frequency component. The wave, the velocity of individual component, velocity of individual frequency component is phase velocity, Vp, right? The velocity of average velocity of frequency component. That means, suppose let us assume this wave has some 10,000 frequency component. The velocity of individual wave is phase velocity. If you add and find the average of all the velocity of individual component, that will give group velocity. That's what the name is group. It is velocity of average velocity of frequency component, right? So let us assume you are running in a marathon. What will happen? So you may run faster than somebody or slower than somebody. So that velocity, that speed is known as phase velocity, individual velocity. But if you take an average of the running speed of all the participants and what is the velocity, that is called average or group velocity. So who will be mostly faster? Individual velocity will be faster. So Vp is always greater than Vg. This is very important, right? The speed of individual vehicle running in a road will be greater than average speed of all the vehicles running in a road. That's what this indicates, right? So Vp must be greater than Vg. Now we solve some problems. Okay. So what is the question is here, right? A uniform plane wave travels in a vacuum at a frequency of 300 MHz in y direction. So its frequency is 300 MHz y direction. What is phase constant? Just now only we have studied phase constant. The other formula for phase constant is omega by b. Beta is equal to omega by b. Right? So why it is omega by b? We know beta is equal to 2 pi by lambda. Multiply and divide by f. 2 pi f divided by lambda f is b. So it is omega by b. Beta is equal to omega by b. They have given in the problem f is equal to what you call 300 megahertz. So 3 into 10 power 8. Okay. Velocity of the wave is 3 into 10 power 8. So beta is equal to omega is 2 pi f, 2 pi into 3 into 10 power 8 divided by 3 into 10 power 8. Cancel. This indicates beta is equal to 2 pi, the unit is radian per second. Sorry, radian per meter, right? So why it is radian per meter? Because beta is equal to 2 pi by lambda. It is 2 pi is in radian, lambda wavelength in meter, so it is radian per meter. So the answer is option B. Next question, you see a wave is traveling in z direction and has two components of electric field. Ex is 5 volt, Ey is 1030 degree. So Ex is 5 volt per meter, Ey is 1030 degree volt per meter. Yes, Ex is represented as pi cos omega t. Ex is phi cos omega t. What about Ey? They are asking. You see 5 magnitude. Magnitude is 5. So here magnitude is 10. This is phase. Here phase 0. So that's why phi cos omega t is 0 degree. That is equal to phi cos omega t. Here cos omega t phase is 30 degree. That is equal to 10 cos omega t plus 5/6. That's what my Ey. So it is 10 cos omega t plus 5/6. Next one, you see, if the electric field intensity associated with the plane wave traveling in a perfect dielectric, dielectric is nothing but free space. Free space acting as a dielectric. So please understand, both are having the same character. So don't say dielectric is a free space, but both are having the same characteristics. So same conditions apply. Wave traveling in a perfect dielectric medium with Ex is equal to 10 cos 2 pi into 10 power 70 minus 0.1 pi z. Right? So what they ask, velocity of propagation. What is V value? Right? So I can find a V value. You see, in general, we compare this with the general equation. General equation is A cos omega t minus beta z. I told in the last class itself. So if you compare, omega is 2 pi into 10 power 7 omega. Fine. What about beta? This is beta. Beta is equal to 0.1. Right? So what I want? V. In the last session only we understood beta is equal to omega by B. This implies V is equal to omega by beta. Omega is 2 pi into 10 power 7. This is 0.1 pi is that, right? So 0.1 pi. Beta is 0.1 pi. Pi cancel. 2 by 0.1 is 20. So 2 into 10. So 2 into 10 power 8. Velocity is meter per second. So 2 into 10 power 8 meter per second. Okay. The next thing is the velocity of EM wave in dielectric media. Right? We know velocity is, I forgot to mention, velocity is given by 1 by root of mu epsilon. So I explained this parameter, velocity. Velocity I told just, so please note this point also. Velocity is equal to mu 1 by root of mu epsilon. Right? For free space, what happens? V is equal to, I can write mu as mu naught, mu r, epsilon naught, epsilon r. So mu r is equal to 1 for free space, epsilon r is equal to 1. I told already. So mu naught, epsilon naught. So if you simplify mu naught, just we know 4 pi into 10 power minus 7. Epsilon naught 8.854 into 10 power minus 12. 1 by root of this one will be 3 into 10 power 8. That's what happens in free space. Right? So this is the meaning of velocity. Right? So velocity is equal to V is equal to 1 by root of mu naught, mu epsilon. But for free space, that is equal to 1 by root of mu naught epsilon naught, that is equal to 3 into 10 power 8. That's why we say in free space, EM wave travels with the speed of light. Right? Because in free space, what is the velocity of EM wave I got? 3 into 10 power 8, which is nothing but speed of light. So this is the thing we have to remember about free space. Now the question is velocity of the EM wave in dielectric medium. So the medium is not free space, it is a dielectric medium. So what we have to do? We know V is equal to 1 by root of epsilon. What they have given? Epsilon r is equal to 4. Epsilon r is equal to 4. So I change mu is equal to mu naught mu r epsilon r 1 by mu naught we know keep as it is. Mu r is not given, so make it as 1. Excuse me. And epsilon naught we know keep it as 1. Epsilon r 4. This I split as 1 by mu naught epsilon naught 1 by root 4. 1 by mu naught epsilon naught, just now only we have seen 1 by mu naught epsilon naught is equal to 3 into 10 power 8. So 3 into 10 power 8. 1 by 4 is 1 by 2, so that is 1.5 into 10 power 8. So what is the velocity of wave in dielectric medium? It is 1.5 into 10 power 8. I told in previous problem, free space and dielectric medium both are representing the same characteristics, but both are not having the same parameters. So you see, in dielectric medium, the electromagnetic wave propagates with the velocity. If epsilon r is equal to 1 of a dielectric medium, it is propagating with the velocity of 1.5 into 10 power 8 meter per second. Whereas in free space, it is always traveling with the 10.8 meter per second. If dielectric medium varies, the speed of the wave will vary depending on the epsilon r value. That's what we learned from this concept. Right? Okay. Excuse me. Next thing is, what's the time? 11:20. Okay. Two coaxial cables, 1 and 2, are filled with different dielectric constant epsilon r1, epsilon r2 respectively. The ratio of wavelength in the two cables lambda 1 by lambda 2 is, right? We have two coaxial cable, C1 with epsilon r1, C2 with epsilon r2. Lambda 1, lambda 2. They ask what is the ratio of lambda 1 by lambda 2. What is the wavelength ratio? Right? Okay. So we know lambda is equal to E by F. Right? They gave only epsilon r. So I must relate lambda in terms of epsilon r, then only I can work. So lambda is equal to V by F. So from V, I know that V is equal to 1 by root of mu epsilon. Since lambda is directly proportional to V, so lambda is directly proportional to 1 by mu epsilon. I know epsilon only. So what is the relationship with lambda and epsilon? Lambda is directly proportional to 1 by epsilon, root epsilon. This we must know. Right? So for first material, first coaxial cable, epsilon is equal to epsilon r1. So lambda 1 is directly proportional to root of epsilon r1. For the second cable, it has epsilon r2. So lambda 2 is proportional to 1 by root of epsilon r2. Because the relationship between lambda and epsilon is lambda is directly proportional to 1 by root epsilon. Or lambda is inversely proportional to epsilon. They gave only epsilon r1 and r2. So what we have to find? Lambda 1 divided by lambda 2. That is equal to root of epsilon r2 divided by epsilon r1. Right? So if we substitute lambda 1 is equal to 1 by root of epsilon r1, lambda 2 is equal to 1 by root of epsilon r2, it will be lambda 1 by lambda 2 is equal to epsilon r2 divided by epsilon r1 square. So root of epsilon r2 divided by epsilon r1. Right? Simple problem. Next step. If the electric field intensity associated with electromagnetic traveling in a perfect dielectric medium is given by this one, what is the velocity? Right? So you see, this is E cos omega. Omega is 2 into 10 power 7. Beta z, so this is beta, 0.15. What is velocity? Omega by beta. I think this question we have already seen, like this only. So the same question but different meaning words. 2 pi into 10 power 7, 0.15. That is equal to 2 into 10 power 8. So option B is the right. What is the wavelength of the wave with propagation constant? This one. So I forgot to mention propagation constant is equal to alpha plus j beta. If you have studied DLW, you must know gamma is equal to alpha plus j beta. This is propagation constant. This is attenuation. This is phase constant. Right? Meter power minus 1. Right? So you can say m power minus 1. What is the wavelength? Lambda. Right? So lambda is equal to, we know lambda is equal to 2 pi by beta, because we know beta is equal to 2 pi by lambda. So from this, lambda is equal to 2 pi by beta. 2 pi beta is 0.2 pi. Here alpha is 0.1 pi. Compare with this equation. Beta is 0.2 pi. So lambda is 10 meter. Option B. Simple problem. Right? This question they have asked. Okay. Now we come to the wave characteristics, wave propagation in lossy dielectric. One minute, please. So change some important points I noted for you. So we know what is dielectric, right? Dielectric is having conductivity. Dielectric is one which has conductivity 0. Good dielectric. It won't conduct. Acts as an insulator, approximately insulator. Sigma is conductivity. Dielectrics won't conduct, so conductivity is 0. Right? It is lossy dielectric. That means conductivity is not 0. Lossy means not good conductor, not good dielectric. That means it may conduct. May conduct in small amount. Fine? Okay, so let us see this. In lossy dielectric, the point we have to remember is one is alpha, that is known as attenuation. Given by omega into root of mu epsilon by 2, root of 1 plus sigma by omega epsilon whole square minus 1. Sorry. Phase constant beta mu epsilon by 2, 1 plus sigma by omega epsilon plus 1. Right? So this is what phase constant. Right? These two equations only you remember. In lossy dielectric, the wave will get attenuated and it has some phase constant. Right? Okay. In lossless, we have to know some parameters. Right? So what are the parameters we have to know about lossless dielectric is, here you see, lossless dielectric means it is good conductor, good dielectric. Here it won't conduct, so sigma 0, conductivity is 0. Epsilon not epsilon r. Next character. Mu is equal to mu naught mu r. Right? So these are all the things you must know. for good dielectric. Okay, and here alpha is equal to 0, beta is equal to omega root of mu epsilon. Velocity we know omega by beta, so it is 1 by root of mu epsilon, right? And eta intrinsic impedance is j omega mu divided by j omega epsilon plus sigma. How it has come, let us see. Right? What is lossy dielectric attenuation? Attenuation is omega root of mu epsilon by 2, 1 plus sigma by omega epsilon whole squared minus 1. Right? So lossless means I told sigma is equal to 0. In this equation, in sigma 0, what will happen? This will be cancelled. So 1 minus 1, 0. So 0, 0. So alpha is equal to 0. That's what attenuation in good dielectric. Clear? Next. What about phase constant? Again, substitute sigma 0, 0, 0. So it will be omega root mu epsilon by 2 into root 1, 1, 1 plus 1, 2. So omega root mu epsilon. So beta is omega root mu epsilon. Velocity omega by beta, this will be cancelling. So velocity is 1 by root of mu epsilon. And eta, you see, eta just now in the first class, in the first video, is PVD itself I told. Eta is equal to j omega mu by j omega sigma. Here, what do you call? Sigma is equal to 0, so it will be j omega mu by j omega epsilon, that is mu by epsilon. That's what intrinsic influence. So these 4 parameters value you must remember. Fine. So this sigma is equal to 0 for ideal case. But practical case, sigma is approximately 0. That is it has very small value. Right? So for problem, we have to use that value only. Right? So what is that value is? When sigma is very small, when sigma tends to 0, that sigma is not equal to 0 means what is attenuation is not 0. It is sigma is given by sigma shit. Here is it. Sigma is equal to sigma by 2 root of mu by epsilon. For problem solving, you use this. Beta is equal to omega root mu epsilon into 1 plus 1 by 2 sigma by 2 omega epsilon whole square. V is equal to omega by beta, that we know. So 1 by root mu into 1 plus 1 by 2 sigma by 2 omega epsilon whole square. And eta is equal to mu by epsilon, that is 1 plus j sigma by 2 omega. These parameters value you use to solve the problems. This is a case, ideal case. Ideal case, any dielectric should have a conductivity of 0. But in practical, it will not be exactly 0. It will be closer to 0, maybe 0, 0, 0, 0, 0.1. So for that case, we have to use this value only. Right? So in problem solving, you can use this only. If they give only this option, you first follow this. Right? Okay. Now we have to come to one important parameter called loss tangent. right? So what is the meaning of loss tangent? Why do we need this, right? So loss tangent, why I need loss tangent is, it is used to find how lossy a particular medium is, right? So this is important parameter, how lossy a particular medium, right? Why we have to study this? It is demarcating conductor from insulator, right? If you want to identify whether a particular medium is conducting medium or a dielectric medium, or conducting or dielectric, we have to understand loss tangent. This parameter is used to demarcate conductor from dielectric. Right? Loss tangent is given by tan theta. Okay, let us see how to find it. Let us know that, let's take this graph. This is JC, this is JD. We know JC is conduction current, that is given by sigma E, right? JD is J omega epsilon E, right? Hope you remember. Del cross H is equal to JC plus JD. JD I write as J omega epsilon E. JD is epsilon dou E by dou T. Epsilon J dou by dou T is J omega, so J omega E. So that's what this one, J omega epsilon E. Fine. So this theta, it is, you see, I draw the line. So we know current in a conductor is due to conduction current GC. I told already in the Maxwell's equation. Current in the dielectric is due to displacement current. Hope you remember in the last class I told. So if I draw the line which is demarcating a conductor from dielectric, right? This line demarcates this line, right? This area is dielectric area, this area is conductor area. Now I take tan theta. Tan theta is nothing but opposite by adjacent. What is opposite side? This side. This is theta. Opposite side is this side. That is JC. Adjacent is this side JD. That is equal to JC is sigma E, right? It is omega epsilon E. So cancel this one. That will give sigma by omega. So I told that tan theta is equal to J omega epsilon. This is what loss tangent. Fine. So the angle is loss angle. This angle theta, I call this angle is loss angle. Whatever they have, this is conductor. Beyond this boundary, this is dielectric. So this is conducting area. So this is very, very important point. So whenever you want to find, see, next question is, if theta is closer to, you see, I will show, if theta is very small, so theta will be like this. If this is a theta, it is closer to dielectric. So similarly, if theta is very large, so if theta comes here, this is theta means theta is becoming large, right? So if theta closer, it is going towards dielectric. The material acts as a dielectric. If theta large, the material acts as a conductor. So theta small, loss angle is small means it is dielectric material. That means theta small means tan theta must be small. Tan theta is equal to sigma by omega epsilon. Sigma by omega epsilon must be very, very small. That is, sigma by omega epsilon must be very, very small. That is less than 1. This means sigma must be less than omega epsilon. So So for dielectric, sigma by omega epsilon must be far less than 1. What about conductor? For conductor, we know theta must be large. Theta large means it will become conductor. This is very, very important point. Theta large means tan theta also large. Tan theta is equal to sigma by omega epsilon. So sigma by omega epsilon must be large. Means sigma must be greater than omega epsilon. So this is a very, very important point, right? So already we know for conductor, it is current due to conduction current JC, there is no JD. So JC must be greater than JD. In it is called dielectric. Dielectric means it should have only displacement current. So JD must be far greater than JC. Here it is conductor, so it is due to conduction current. JC must be far greater than JD. These are all very, very important. Okay, right. This is what we must remember. So when you want to identify whether a given material is dielectric or conductor, you use this formula. Sigma by omega epsilon E must be less than 1 means dielectric. Sigma by omega epsilon is greater than 1 means it is conductor. Right? Now you see the question. A distilled water at 25 degrees is characterized by sigma is equal to 1.7 into 10 power minus 4. Sigma is equal to 1.7 into 10 power minus 4. And epsilon is equal to 78 epsilon naught. Epsilon is equal to 78 epsilon naught. Frequency 3 gigahertz. F is equal to 3 gigahertz. What is loss tangent? Loss tangent tan theta is given by sigma by omega epsilon. Sigma 1.7 into 10 power minus 4 omega 2 pi f 2 pi into f 3 into 10 power 9 epsilon is equal to 78 epsilon 78 epsilon naught we know it is 10 power minus 9 divided by 36 pi. So what happens? Or epsilon naught is equal to 8.854 into 10 power minus 12. You can use anything. But why I use 36 pi? Because already we have the 2 pi. So I can cancel this. 1 by 80. So 1.7 into 10 power minus 4. 10 power 9 becomes 10 power plus 9. This 38 will come out 3 into 10 power 9 into 78 is approximately 1.3 into 10 power minus 5. Right? So the answer is 1.3 into 10 power minus 5. Next, main wave propagation in conductor. Right? This property is also very, very important. For that, you just remember the formula. Here, alpha is mu omega sigma by 2. That is equal to beta. Both alpha and beta are same. But okay, alpha is unit of dB per meter. Beta is unit of radian per meter. That is the only difference. Velocity is given by 2 omega divided by mu sigma meter per second. Eta is equal to j omega mu divided by sigma. It is impedance. So, right? Now, the next parameter, very, very important parameter, lot of questions will from this area, skin depth. Sorry. So what is skin depth? It is a measure of depth to which an EM wave can penetrate the medium. So how much a EM wave penetrate through the medium is given by skin depth, or it is defined as the depth at which the wave gets attenuated to 37% of its original value. Right? So this is what skin depth, that is given by delta. So delta is equal to 1 by alpha. Alpha is attenuation. Fine. So right. So I want to emphasize something. We know alpha is equal to omega mu sigma 2. That I can as 2 pi sigma. So it is pi f mu sigma for conductor. So delta is given by 1 by root of pi f mu sigma. This is the formula we will use to solve the problem of based on this formula. They asked so many questions, so please understand. Okay, fine. Let us see and solve the problem. Right? Okay. The problem number 1. Fine. Here you see some unknown material has conductivity. So sigma they have given 10 power 6 mole per meter. Permeability mu 4 pi into 10 power 7. What is the skin depth? F is equal to 1 gigahertz. Skin depth del is equal to 1 by root of pi f mu sigma 1 by pi. Mu is 4 pi into 10 power minus 7. F is equal to 1 into 10 power 9. Sigma is 10 power 6. If you simplify, what you get is 15.9 micrometer. Right? Simple problem. The other name for skin depth is depth of penetration. Both are same only. Skin depth or depth of penetration. The depth of penetration of electromagnetic wave in a medium having conductivity sigma at a frequency 1 kilohertz. So F is equal to 1 into 10 power 3 hertz. As conductivity at the frequency is 25 centimeters. So they have given the skin depth value del is equal to 25 into 10 power minus 12. So 2. The depth of penetration. So this is what the depth of penetration at a frequency F1 at a 10 power 25 centimeter. What is depth of penetration at 4 kilohertz? So they have depth of penetration for 1 kilohertz is 25. What is the depth of penetration for 4 kilohertz? So we know del 1 is equal to 1 by root of pi f1. Mu will not vary, sigma, right? So similarly, del 2 is equal to frequency only they changed it. Pi f 2 mu sigma. I want del 1 by del 2. If I do this, what I get is f2 by f, right? So what I want is del 2, right? So you see del 1 by del 2 is equal to F2 4 kilohertz 1 kilohertz. This is 4k 4 into 10 power 3. It is 1 into 10 power 3 4. Del 2 is equal to del 1 by 4. I want del 2. Del 1 is 1. Del 1 is 25. Sorry, 4 by root 4, that is equal to 2. So del 2 is equal to del 1 by 2. Del 1 is 25 centimeter. 25 into 10 power minus 2 divided by 2. 12.5 into 10 power 12.5 centimeter. So the answer is 12.5 centimeter. Next question is, the depth of penetration of a wave in a lossy dielectric medium increases with increase in lambda. Why? Let us see. We know del is equal to 1 by alpha, right? We know alpha is directly proportional to frequency. Alpha is directly proportional to frequency from our see, alpha is directly omega is 2 pi. Alpha is directly proportional to frequency. So when alpha is directly proportional to frequency, this indicates del is indirectly proportional to frequency. Right? We know C is equal to F by F into lambda. So this implies F is equal to 1 by lambda. They ask conductivity, permittivity, and permeability. So wavelength only. So I have to write del in terms of wavelength. So del is inversely proportional to 1 by F. That is equal to 1 by F is directly inversely proportional to C by 1 by lambda. So it will be lambda. So the depth of penetration is directly proportional to lambda. Del is directly proportional to lambda. So skin depth of a wave in a lossy dielectric increases with the increase in wavelength. So option C is the right answer. Fine. And the next one, which is the skin depth of a copper at the frequency. F1 is equal to 3 gigahertz. Skin depth they have given 1 micron, 10 power minus 6. At F2, 12 gigahertz. It is non-magnetic conductor. Conductivity is 1 by 9 times that of copper. So del 2 has conductivity sigma 2, which is first material is sigma 1 copper. 1 by 9th times of the copper. That is the point. That is equal to this one. What is the skin depth of the second one? Fine. So that's what we have to find. Okay. So we know first one has 10 power minus 6 as skin depth. That is equal to 1 by root of pi f. Frequency varies f1 mu sigma 1. Second one is del 2 1 by root of pi f2 mu sigma 2. Right? So this is you assume as del 1. So del 2 by del 1, if you simplify, what you get is pi mu cancel, mu del 2. Okay, del 2 is f1 sigma 1 divided by f2 sigma 2. Substitute del 2 and del 1 value and you get this one. Del 2 by del 1, f1 3, f2 4, 12. 3 into sigma 1, 12 into sigma 2 is sigma 1 by 9. Right? So this is equal to 9 by 4. Del 2 by del 1 is 9 by 4. So they ask the skin depth del 2 by del 1, it is root of 9 by 4 microns. Right? That's what we got, del 2 by del 1, the ratio. Right. So next we talk about wave propagation. Um, okay, here you see which one of the following field pattern represents TEM wave traveling in positive x direction. So the wave should propagate in plus x, right? If the wave should propagate in plus x, we know E cross H will give wave propagation direction. This must be x. So in what are the ways you can get x here? Your E may be in y direction, H may be in z direction, y cross z is equal to x. Clear? Otherwise, your E may be in minus z direction and H may be in y direction, that will give x. We know y cross z is equal to x. Z cross y minus x, so this minus will become plus. Otherwise, you may have minus y minus z. Y cross z, x minus minus plus. So these are all the three options. Fine. Here you see which options are matching. So this is E, this is H. E is equal to plus y plus z, plus y minus z, plus y. No, this is wrong answer. This is not possible. Right? Z must be minus. So this is wrong. Plus y minus z, plus y minus z. Is there anything plus y minus z? No. Minus y minus z, minus y minus z is present. Minus y plus z, no. This is minus y plus z, no. Wrong. So the option B is the right answer. This is based on pointing power flow, right? Anyway, we know that electromagnetic wave will be perpendicular to each other. E is perpendicular to H, that is perpendicular to wave propagation. That concept we can use, but we must know that. You know the intrinsic impedance of Nazi dielectric medium already. J omega mu by J omega epsilon plus sigma. Next, the electric field component of a uniform plane wave propagating in y direction in a lossless medium will satisfy wave equation. When the wave propagates in y direction, the electric field and the magnetic field should not be in y. So Ey must be 0, Hy must be 0. Because wave is in y direction. So E must be in either x or z. So this is telling Ey component, so this is wrong. This is also telling Ey component, this is wrong. Right? So the wave should propagate in y direction. So this is component. If you have any doubt, please refer our last class. This is direction. Electric field is in y direction. Dou squared Ex by dou y squared. Mu epsilon dou squared Ex by dou t squared. So this is right answer. This is also right, right? So just you take this. This is a perfect answer. Okay. And the intrinsic impedance of a copper at high frequency. So we know intrinsic impedance of a copper at high frequency. So we must know beta is equal to J omega mu, J omega epsilon plus sigma, right? Copper means high conductivity. So conductivity means sigma is greater than omega epsilon. So this is negligible, j omega mu by sigma. So this I write as omega mu. J is nothing but e power j pi by 2. Why e power j pi by 2 is cos pi by 2 plus say sin pi by 2. Cos pi by 2 0 is j. So j is e power j pi by 2. So omega mu into e power j pi by 2. Fine. So this is given divided by sigma, right? So omega mu divided by sigma e power j pi by 2 I write as multiply by I take root of e power j pi by 2. Root of e power j pi by 2 is e power j pi by 4. So e power j pi by 4 that is equal to omega mu divided by 2 e power j 45. You see this is positive and eta is positive. E power j pi by 45 degree is positive. So when it is j, so it is a complex. E power j is a cos 45 plus j sin 45. So eta is complex in nature. So we have eta r plus eta j eta I. Real part of eta r, real part of eta I. Imaginary part. So e power j is 45 cos 45 plus j sin 45. It is a complex number. So eta is a complex number. So it is plus 45. Plus means inductor. Minus means capacitive. That we know from circuit theory. So it is complex with the inductive component. Fine? Okay. Okay, this is what another question they ask. The material with the following electrical parameters. F is equal to 10 gigahertz. I do here. F is equal to 10 gigahertz. Sigma is equal to 10 power 6. Epsilon naught mu is equal to mu naught. Epsilon by epsilon naught is equal to 10. Epsilon naught is equal to 10 power minus 9 divided by 36 pi. That is equal to 8.854 into 10 power minus 12. That you remember. Okay. Now what they ask, the material at this frequency is considered whether it is dielectric or conductor, either dielectric or good magnetic material. To check whether the material is dielectric or conductor, I told first we have to find sigma by omega epsilon E. Say omega epsilon. If it is far greater than 1, conductor. Less than 1, dielectric. So sigma 10 power 6. Omega 2 pi f 10 into 10 power 9. Epsilon is equal to epsilon by epsilon naught is equal to 10. So epsilon is equal to 10 epsilon. 10 into epsilon naught. Simplifying, this 10 power minus 9 will become 10 power plus 9. 18. 10 into 10 power 9 into 10. Fine. So it will be equal to 10 power 9, 10 power 9, 10 power 2. So 18 into 10 power 4, which is far greater than 1. So sigma by omega epsilon far greater than 1. So it is a conductor. Good conductor. So it is very good conductor. Next, a material has conductivity sigma 10 power minus 2, relative permittivity 4, the frequency at which conduction current in the medium is equal to displacement current. We have to find AF at which JC is equal to JD. Fine. So JC is equal to JD. JC is sigma E. This is omega epsilon E. So E cancel, right? So what will happen? sigma is equal to omega epsilon. This implies F is equal to sigma by, okay, write as 2 pi f e. I want F 2 pi epsilon. 2 pi epsilon. Sigma 10 power minus 2. 2 pi epsilon naught 10 power minus 2. 2 pi epsilon r. You see, it is a material, not free space. Epsilon r is 4. Epsilon r is 4. Epsilon naught 8.85 into 10 power minus 12 or 10 power minus 9 divided by 36.18. This implies F is equal to 45 into 10 power 6. That is 45 megahertz. Fine. So 450 or 45 megahertz, right? So the option A is the right answer. Clear? Next, wave propagation, normal incidence on a conductor boundary. Fine. These are all very, very important. Okay. So far we studied when a wave propagates through a conductor or dielectric medium. That is homogeneous medium. Homogeneous medium means the medium is location, the parameters are independent. When wave propagates through, either the full medium is conductor or fully dielectric. That's what we have studied. But if wave propagates through different medium, left hand side dielectric or free space, right hand side conductor, what will happen here? What will happen here? That's what we have to know. Where we can see this scenario, we know our free space is sky. When wave is coming from satellite and reaching antenna, and from there it is traveling through TLW and reaching our TV set. Here free space, here it is conductor. What happens here? That's what we are going to study. So in this location, antenna is a conductor, it is free space. What happens over here? That's what we are going to learn. What is the nature of wave propagation when it is normally incident on a conductor boundary? Okay, let us start. Right? So let us assume wave propagates. This is the direction. This is X direction. Right? So this is free space. That is our space. Conductor. This is medium 1. This is medium 2. It has parameters, constitutive relations, mu1, sigma 1, epsilon. It has mu2, epsilon 2, sigma 2. Right? And this is boundary. Here it is boundary. Boundary between two medium. Fine? Okay. Right? So it has intrinsic impedance eta 1. In free space, we know it is 377 ohm. It is having eta 2. We don't know what is that value. The wave comes from here. Right? It's a wave. Here the electric field has only H component. Everything is lost. Please bear with me. Conductor mu1 sigma 1 epsilon 1 eta. So mu2 sigma 2 epsilon 2 eta 2. Free space mu1 sigma 1 epsilon 1 377 eta 1. Fine. And medium 1, medium 2. This is what boundary, z direction. This is x direction. The wave propagates through this and it has electric field along x direction. Wave in z direction. E is along x direction. Wave propagates in z direction. Okay. So if E is in x direction, I don't know what is h direction. Wave is in z direction. So x cross something should be z. So what should be the h value? Y. Because E cross h is equal to wave direction. So as per pointing vector. So h must be in y direction. Y means coming out. This is h. Here it is E. Here the wave goes. Right? So you see, when wave propagates like this, it has only x component. So it is having component like this, Ex, because it has only x component. When it reaches the boundary, it is touching tangentially. So what is E tangential? E tangential electric field along the tangential component of electric field is 0. If you have any doubt, last class itself I told boundary condition. Otherwise, you refer my video on boundary condition in EC 8451 lectures. Right? Okay. So E tan is equal to 0. Tangential component is 0. Moreover, inside this, conductivity is 0 because electric field inside here is E is equal to 0. Because E0 inside a conductor. Sorry, not conductivity is 0, electric field is 0. Since it is a conductor, electric field is 0. So all the wave gets reflected in x direction. This is forward, this is reflected wave. Fine. So this is forward wave. This is E direction, H direction, wave direction. In reflected wave, again E is along the x direction, but wave is traveling in minus z direction. Right? So if E x cross something should be minus z. So where it should be minus y. X cross minus y is equal to minus z. So when the wave gets reflected, E will be in x direction only. X. Wave will propagate in x the minus z direction. Right? Here wave propagates and h should be in minus y. That means go inside. Here coming out plus y. Here go in. These things we must remember, right? Whenever we want to deal this, right? And the important formula, the thing we have to remember is in conductor dielectric boundary in free space, conductor boundary, what are the values? Here E is given by 2EI sin beta z into sin omega t ax. E is in x direction. H is equal to 2 eta I by eta cos beta 1z You know, E is in X direction, H will be in Y direction. And moreover, cos omega t sin omega t plus pi by 2, you see, sin this sin omega t plus pi by 2. E and H are 90 degree out of phase, perpendicular. These two indicates E is perpendicular to H. And EX, it is in X direction, it is in Y direction, X, Y, perpendicular. Fine. This is the one thing we must remember. 2. Fine. What is Emax? Maximum value is this one only, because sin maximum 1. So this sin maximum has maximum value of sin has a maximum of 1. So Emax equal to 2EI. Right? Whenever you put Z is equal to n lambda by 4. Why? Sin beta Z you take beta is equal to 2 by y lambda, n lambda by 4, lambda lambda cancel pi by 2. Sin n pi by 2 always 1. So that's what E max. 3. When Z is equal to 0, here Z is equal to lambda by 4. When Z is 0, what will happen? When Z is 0, sin 0. So E is equal to 0. Fine? Okay. Fourth one. See, Z is 0 means what? This is Z. Right? So here electric field must be 0. Right? On the boundary, the electric field is 0. So the electric field is 0 along the free space conducting medium boundary. This we must remember. Right? Very, very important concept. Okay. Next, we have to find what is E mean. Right? So those things we can find. Right? This is the way we can work on this. Similarly, we will deal with the H. See, moreover, another thing we have to remember is E is equal to 2 sin beta Z sin omega t. What is the general formula? It is cos omega t minus beta Z, or sin omega t minus beta Z. Here you see omega t is there. There is no phase. This component is absent. Compare these two. This is missing. If this is a traveling wave, we have phase means it is traveling wave. Here you see phase 0. Beta Z component is 0. That means it is a standing wave. So the electric field acts as a standing wave. Similarly, magnetic field also standing wave. There is no beta component. So this is also standing wave. Right? These are all the important points you must remember when you deal with the free space on conducting boundary. Fine. So similarly for magnetic field, H is equal to 2EI by eta we know, cos beta Z, cos omega t AY. Again, it is a standing wave. Second, we must know what is the maximum. H max is cos maximum of 1, cos, this is a cos also maximum of 1, 2EI by eta. E1 by A or something. Third one, at beta is equal to, or Z is equal to n lambda by 2. Why? You see beta is equal to 2 pi by lambda. Here Z is equal to n lambda by 2. 2 cancel, lambda cancel, cos n pi. N0 means cos 0 pi, 1 means cos pi. So cos has a maximum at 0 pi, 2 pi like that. So H has maximum 2 at 2e by eta. Simply put eta, 2e. This also you can put 2e. Or incident, right? That's what I mean. Then H minimum is equal to 0. Cos will be 0 at when pi by 2. So at z is equal to n lambda by 4. Why? You put beta. Beta is 2 pi by lambda z. N lambda by 4. Oh, sorry, lambda lambda cancel. It's 2 pi by 2. Cos pi by 2 0. Cos 3 pi by 2 0. So h minimum occurs at this point. Right? So these are all things we must know. And another thing we must know is this is very, very important formula. Reflection coefficient of electric field in free space, normal incident. That is given by ER by EI is equal to eta 2 by eta 1 divided by eta 2 plus eta 1. So what is this? The reflection coefficient of a EM wave in the free space conducting body. What is reflection coefficient? Out of how much electric field incident, how much is reflected? That is given by eta 2 minus eta 1 divided by eta 2 plus eta 1. Eta 2 is intrinsic impedance of the second medium. Eta 1 is free space. That is 377. Yes or no? We see eta 1 377, eta 2 they will give in the problem. They will solve. This is what reflection coefficient by electric field. Next, transmission coefficient, transmission coefficient tau of electric field is given by 2 eta 2 divided by eta 1 by. This is reflection coefficient. This is transmission coefficient. Similarly, for magnetic field, tau h gamma h tau h. These four formulas are very, very important. This is reflection coefficient for electric field, transmission coefficient for electric field, reflection coefficient for magnetic field, transmission coefficient for magnetic field. Right? So please remember this. Now we solve. Okay. This is a beautiful question. You see a wave from free space fall into a conducting medium. What is the value of transmission coefficient? So what they have given? Eta. So the medium eta, that is eta 2 they have given. Right? So what is transmission coefficient? We know tau t is equal to 2 eta 1 divided by eta 1 plus eta 2. Fine. So transmission coefficient tau 2 eta 2 divided by eta 1 plus eta 2. Okay. So what is 2 eta 2? 2 eta 2 is 123. 2 into divided by eta 1. First medium is conducting medium. So it is 377. So 377 plus 123, that will be equal to 2 eta 1, right? 2 eta 1. So 2 into 377 divided by, so 2 into 377, 754 divided by 500, right? 1.508. Fine. So that is the answer. Transmission coefficient. Okay. Next one, you see a plane wave is propagating in air with the electric field is incident on a perfectly conducting slab cushioned at x is equal to 0. What is the electric field of the reflected wave? Right? So you see, this is the way it is coming. It is E. E has 8ax plus 6ay plus 5az right, into this e power j something. This is reflector. Reflector means all the directions are completely changing. So ax becomes minus ax, ay becomes minus ay, az becomes minus az. So it is 8ax means minus 8, minus 6, minus 5. This will be same, right? So what the answer is? Okay, right? So this is minus 8, minus 6, minus 5, right? Omega t, fine. This one 3x plus 4. Right? This is the answer. Okay. This should, all the three should change. Fine? Okay. Next. For a electromagnetic wave, incident from one medium to a second medium, the total reflection takes place. We know the total reflection takes place from our physics itself. We understood, right? When wave moves, total internal reflection takes place. When wave propagates from denser medium to rarer medium. From denser medium to rarer medium, right? And angle of incidence must be greater than critical angle, right? So option C is the right answer. Clear. So we know sine theta I, angle of incidence is equal to sigma 2 must be epsilon 2 by epsilon 1. Sine theta C is right. So first I write this. Sine theta C is epsilon 2 by epsilon 1. Theta I must be greater than incident angle. So sine theta I must be greater than incident angle. It's a critical angle. Critical angle is epsilon 2 by epsilon 1. So the angle of incidence is equal to critical angle or greater, and it should move from denser medium to rarer medium. Right? So this is wrong. Right? So those things are okay. In a good conductor, what do you call the phase relation between tangential component of electric field and magnetic field, right? So you see in good conductor, eta is equal to E by H. This is the relation giving electric field and magnetic field, right? In good conductor, we know J omega mu by J omega epsilon plus sigma. In good conductor, sigma is far greater than omega epsilon, so it is J omega mu by epsilon. J is nothing but e power j pi by 2 I told her, that will become j pi by 4. So this I have already seen, e power j pi by 4. So mu sigma by 2, this angle is 45 degrees. Right? So what is the thing? This is what E by H. E by H, that is equal to eta, that is equal to root of mu sigma by 2, 45 degree. So if I take E is equal to H 45 degree. So E leads H by 45 degree. So E leads H by 45 degree. It is not 900. So option D is the right answer. Right? A TEM, not TEM wave. A TEM wave is incident normally upon a perfect conductor. The electric and the magnetic field at the boundary will be. Just now only we have seen when electric field comes, it is reflected. Fine. At the boundary, electric field I told already, it is 0. So electric field is minimum and the magnetic field will be reflected, so it is maximum. So E is minimum, which is maximum. So option C is the right answer. Because E tan 0 already I told. So that's what I emphasized. At the boundary, electric field is 0. At the boundary, tangential component is Hi plus HR. Incident wave plus reflected wave. Right? At the boundary, EI plus ER, that is equal to 0. Yes or no? So here you see whatever incident that is reflected. So HI is equal to HR in tangential component. So 2HR maximum. That is equal to 2HI. So electric field is minimum and magnetic field is maximum. Next, the uniform plane wave traveling with air incident on the plane boundary between air and another dielectric medium. So free space and dielectric with epsilon r is equal to 4. What is the reflection coefficient? Reflection coefficient I form I told eta 2 minus eta 1 divided by eta 2 plus eta 1. Right? So find the values. I told how to find epsilon r and all. Substitute and what is the answer you will get is 0.33180. Right? So try this problem. If you have any doubt, please ask me in comment section. Right? So I think are you audible? Is there any message from you? Okay. Fine. Next. So this is another one beautiful question. This also you can try. If you have any doubt, please ask me. WhatsApp or my channel. I have given everything there, right? My channel address I have given in the PPT. Majid lectures. Now we see wave polarization. This is another important point we have to remember. Fine. Okay. So from this one question, surely they will ask, right? So the wave polarization. What is polarization? Polarization is nothing but orientation of electric field. Fine. So it is nothing but orientation of electric field. So we have three type of polarization. One is circular. Sorry, first linear. We go to linear, elliptical, circular. Right. So these are all the three types of polarization we must know. How to identify? I don't deal the concept. I just give a shortcut. In linear polarization, the phase shift between two components. Let us assume our E has Ex and Ey. Phase shift between Ex and Ey must be 0. In circular and elliptical polarization, phase shift is not is equal to 0. It is plus or minus pi by 2. Then how can you find elliptical and circular? In elliptical and circular, we have to take the magnitude. If Ex value is equal to Ey, circular. If Ex is not equal to Ey, it is elliptical. So this is a shortcut. By using this, you can solve many problems. They have asked so many problems in this. And another one thing is, if they give positive phase shift, it is left side. If they give negative, it is right side. Right? This is another important thing. So just to remember these 5 concepts and you can solve all the problem. How it has become left side and right hand side and all, you refer my video on electromagnetics, right, that I have explained. Now you see, the first question, they have given Ex value, 2 cos omega t. Ey value plus 90. So the phase is different, not 0. So surely it is not linearly polarized. And check amplitude. Amplitude, this is Ex. Ex has amplitude of 2. Ey has amplitude of 2. So both are circular because both are same. So circular. If it is not same, elliptical. So circular polarization. Cut. Whether it is left circular or right circular, I told you. Plus symbol means left circular. So it is plus symbol. So it is left circularly polarized. Simple. Fine? Okay. Next. Here you see the electric field of an electromagnetic wave propagating in positive z direction. Here, what is the phase? Omega t minus beta z, omega t z plus pi by 2. So it is not linear. So linear, wrong. Fine. And Ax, Ay, What is the magnitude? Here it is 1 dot. Here is also 1 dot. Right? Ex magnitude is 1. 1 is here it is 1. So Ex equal to Ey. So circular. So it is not ellipse. Right or left? Plus pi by 2. Left. Fine. So this is one answer. Here you see the polarization of wave with the electric field vector. Right? So I write it fully E naught Ax plus E naught Ay e power j omega t minus beta z. Is there any phase variation? There is no phase variation. Phase is equal to 0. Phase 0 means surely it is linear. It is not ellipse or circular. Right? Because pi is equal to 0. Linear polarization. Here you see E. This is 0.5. I write as E is equal to 0.5x. So this 0.5. X component is 0.5. Y component is 1. Right? And you see, you may feel that there is no phase difference. No, here we have e power j pi by 2. E power j pi by 2 introduce, if you add with this, when you multiply, it will become e power j omega. When you multiply these two, what it will become? 0.5x e power j omega t minus j kz plus 1 into y vector e power j omega t minus kz. This will become plus pi by 2. So phase difference is 90 degree. So pi is 90 degree. Pi 90 degree means it should be either ellipse or circular. But Ex is not equal to Ey. So it is elliptically polarized. Clear? Okay. Here you see what is the the uniform or the electric field of a uniform plane electromagnetic wave in free space, propagating in x direction, given by this one. What is the frequency and the propagation of the wave? Right? So how can we find frequency? So first I write it. E is equal to 10 ay plus j az e power minus j 25. Compare with the general formula. We know general formula is a ay plus j. Just simply for understanding, a is a e power j omega t minus beta z. Here omega t is 0. Beta is, here it is for z direction. As per the problem, they give wave is in x direction. That's why it is x. So what is beta if you compare? Beta is equal to 25. What they ask, f. We know v is equal to omega by beta. From once you find v, we can find, we know v omega. So this is equal to 2 pi f by beta. This implies f is equal to v into beta by 2 pi. V is 3 into 10 power 8. Beta 25 divided by 2 pi. It is approximately 1.2 gigahertz. Fine. So 1.2 gigahertz. So these two are wrong. Since both are having the magnitude, it is 10. Here also multiplied by 10. So Ex equal to Ey. So circular. But whether it is left circular or right circular, J. I told J means e power j pi by 2. Right? Already I told. J indicates e power j pi by 2. So when you multiply with this, it will increase the phase of pi plus pi by 2. Plus means left circular. So option A is the right answer. Next you see whether the time sinusoidally time varying vector field 2 cos omega t plus 2 cos omega t minus 30 phase is same? No. Phase is different. Phase is not equal to 0. Phase 0 means linear. Okay, linearly polarized. This is 2. This is 2. Ex is equal to Ey. So it should be circular. And the phase difference. Circularly, there is no x. Right? So in this way only we have to identify the answers. Clear? So that's all about this session. I hope you understand everything very clearly. If you have any doubt, please ask me. I am here to answer your doubts. Students, doubt. Any doubt? Any doubt, please? Please ask me. If you have any doubt, we can ask. Anyone? Any doubt from anybody? Okay. Thank you for your patient listening. So if you have any doubt, you can ask me in this lecture, YouTube lecture also, Majid lectures. Otherwise, you can WhatsApp and get your doubts clear, right? So here I have put everything in detail. All the gate questions I solved, TRP questions I solved, it will be useful for you, right? Thank you so much. Thank you.